In this lesson, we are going to talk about intervals where the function is increasing or decreasing. There are a lot of situations that you, as the owner of a company, you want to know when the production is going to increase and when the production is going to decrease. Since the production is directly related to the profit that your company makes, knowing this information is going to be very productive. To do this, we are going to use the first derivative of a function f, which is continuous through its domain. We know that the first derivative of a function f of x is just the slope of the function evaluated at every single point in the domain. We also know that when the slope is positive, the function is increasing, and when the slope is negative, the function is decreasing. This is going to give us an indication of how to find when the function is increasing or decreasing. The only thing we have to do is to find the first derivative of the function f prime of x, and if f prime of x within an interval is positive, then we know that the slope is positive, so the function is going to increase. And when the derivative is negative in an interval, then we know the slope is negative, so the function is decreasing. The first example is asking us to find the intervals of increase and decrease for the function defined by f of x is 2x cubed plus 3x squared minus 36x plus 5. As we said before, to find the intervals of increasing or decreasing, we just find the first derivative and then we make it equal to 0. So f prime of x is going to be 6x squared plus 6x minus 36. We make it equal to 0. We can factor 6 out. So from here I get x squared plus x minus 6 is equal to 0. Now I can factor this one as two brackets. The product is negative 6 and the sum is 1. So this gives me the two numbers x plus 3 and x minus 2 equal to 0. Now the roots are x is equal to negative 3 and x is equal to 2. Now to find the intervals, I'm going to use a table like the one I'm going to show down here. One row I'm going to say f prime, the other row I'm going to say f. Now I'm going to put these values, x equal to negative 3 and x equal to 2. When x is equal to negative 3 here, x equal to 2 here. Now x can be less than negative 3, x can be between 2 and negative 3, and x can be greater than 2. Now in each interval or point, I'm going to see the sign of f prime. When x is less than 3, I'm going to pick a number less than 3, let's say 4. Then I'm going to sub it back in f prime. So f prime becomes 6 times 4 squared plus 6 times 4 minus 36. I'm using f prime, which is given here. Now if I evaluate this one, 6 times 4 squared plus 6 times 4 minus 36 is going to give me 84, which is going to be a positive number. When x is negative 3, we know that f prime is 0. Between negative 3 and 2, let's pick a number like 0, simple one. So I get 6 times 0 squared is 0 plus 6 times 0 is 0 minus 36. So it's going to be a negative number. When x is 2, I know it's a 0, so it's going to become 0. For x greater than 2, let's pick a number like 3. So I'm going to get 6 times 3 squared plus 6 times 3 minus 36. 6 times 3 squared is going to be 6 times 9 is 54 plus 18 is going to give me 72 minus 36 is 36, which is a positive number. Now, looking at the sign, I can see because f prime is positive here, the function is increasing. At x equal to negative 3, we know that the slope is 0, so it's going to be a horizontal line. I show it with a horizontal line or a negative sign. Between negative 3 and 2, I know it's negative, the sign, so it's decreasing. At x equal to 2, I know that it's going to be a horizontal line, the slope. And at x greater than 2, we know that the function is increasing. So overall, I can say that f of x is increasing for x less than 3 and x greater than 2. And f of x is decreasing for x between 2 and negative 3. And at x equal to negative 3 and x equal to 2, it's going to be a maximum and minimum. Just look at the table here. You can see that the function is increasing, then it becomes horizontal, then goes down, becomes horizontal, goes up. So this means that at this point, x equal to negative 3, the function is maximal, and at x equal to 2, the function is minimal. The next question says, for each function, use the graph of f prime to sketch a possible function of f of x. Just remember that it says a possible function. This means that there are infinite number of solutions, and we are going to just plot one of the possible functions. The first one, a, is just showing us that f prime is always negative 2. Since f prime is less than 0, then we know that the function is decreasing all the time. Now, f prime is the slope of the line, which is equal to negative 2. So this means that my original function is going to be a line which is going to have a slope of negative 2. So one possible answer is like this one. I can say when x is equal to 1, the slope has to be negative 2. So y can be a point like here, negative 2. When x is 1, y is negative 2. When x is negative 1, y is 2. The slope again is going to be negative 2. Connect these two together, and I'm going to get a line which goes through these 2 points. This is one possible function f of x, which is going to have f prime equal to negative 2. Remember, the equation of this line can be written f is equal to negative 2x plus a y-intercept, call it c. Now, if I take the f prime is going to be negative 2, and the derivative of a constant is 0. And I'm going to get exactly the same equation for f prime, which is negative 2. The next graph is graph B, which shows us f prime, which is a line. Now, what is important when we look at the f prime is where f prime is 0, because whenever f prime is 0 is when the function is either maximum or minimum. You can see that at x equal to 2, f prime is 0. So I'm going to come up again with a table like the following. I'm going to say f prime at x equal to 2, x less than 2, and x greater than 2. Now, when x is less than 2, we can see that f prime is here, this part, which is positive. At x equal to 2, f prime is 0, and at x greater than 2, which is this part, f prime is negative. So this means our function is increasing, levels off here, and then decreasing here. So the function looks like the following. This means that one possibility is going to be a graph like this one, a parabola which is opening downward. Now, another way of looking at this one is the following. I can go ahead and find the equation of f prime. I know that the line representing f prime goes through the point 2 and 0 and 0 and 4. I can find the equation of this line by finding the slope. Slope is 4 minus 0 is 4, 0 minus 2 is minus 2, which is going to be negative 2. So the equation becomes negative 2x plus b. But to find b, I know that one of these points can be substituted and I can find b. So let's try 0, 4. So I say 4 is equal to negative 2 times 0 is 0 plus b. So b is equal to 4. So my equation of the line is negative 2x plus 4. Now, I know that this y is really f prime. I can do the reverse of derivative. In fact, you will learn it later on when you go to university that the reverse or opposite of derivative is integration. So I'm going to say f of x is what function, when I take the derivative, I get 2x. Forget about the sign. The function is negative x squared, because when I take the derivative of negative x squared, I get negative 2x. What function again gives me the derivative 4x? Obviously, it's 4x. If I take the derivative of 4x, I get 4. And remember, the derivative of any constant is 0. So I can add a constant here, c. The derivative of this function is going to give me this one. Now, if you look at this f of x, this is a quadratic. I can find the equation of quadratic in vertex form. If you go ahead and find the equation in vertex form, assuming that c is 0, c is a constant, so I set it to 0. So I'm going to get this equation, negative x minus 2 squared. And this one represents a parabola which opens downward, and the vertex is at 2 and 0, exactly what we have here. Now this means that I can move the parabola upward or downward by changing the value of c here. And still that parabola is going to be represented, the first derivative, by this line. That's why the question says a possible function for f of x. The next question is the graph in C. We have to find the graph of function f of x if this parabola is f prime of x. Again, as before, I'm going to create a table for f prime with the major points. The only major point I have is this point, which is 1. So when x is equal to 1, when x is less than 1, when x is greater than 1. When x is 1, I know that the derivative is 0. When x is less than 1, you can see that the graph is positive, f prime is positive, and when x is greater than 1, also it's positive. So this becomes increasing, levels off, increasing. Now, the function f of x is going to look something like this one. You can see that it's increasing here, it's increasing here, and it's leveling off right here. The next question, which is D, is telling us to find the graph of function f of x. Again, we are going to find the points where f prime is 0. The points are here at 1 and 3. So I'm going to write the table again. So at x equal to 1, x equal to 3, x greater than 3, x between 3 and 1, and x less than 1. I know that at 1 and 3, derivative is 0. When x is less than 1, meaning this region, you can see that f prime is negative. When x is between 1 and 3, which is here, f prime is positive. When x is greater than 3, which is here, f prime is negative. Now, f prime is negative, so this means that f is decreasing. 0 means it's leveling off, increasing, leveling off, and decreasing. If I connect these together, I can see that this is leveled off, up. So it looks like a cubic function which is shown in this table. Now, these points corresponds to points here. So if I pick this point here and this point here, I can draw something like here. So this point, which is the maximum, corresponds to here, 3. This point corresponds to minimum, which is this point, and the function is decreasing here, and the function also is decreasing here, and it is increasing in this region. In the next example, we have the temperature of a person with a certain strain of flu, which is approximated by the function Td, where d is between 6 and 0, and T represents the person's temperature in degrees Celsius, and D is the number of days after the person first shows the symptoms. The question is that during what interval will the person's temperature be increasing? To find the interval, we need to find the first derivative of T. So T prime is equal to negative 5 over 18 times 2D plus 15 over 9. 2 cancels with 18 and gives you 9. We have to make it 0, so we get 3 over 9, 5 over 9, D is equal to 15 over 9. 9 cancels with 9, so D is equal to 3. This means that on a number line, if D is equal to 3, which means that the tangent is horizontal or the slope is 0, when D is less than 3, let's say D is equal to 0, we get T prime of 0 becomes 15 over 9, which is positive, and when D is greater than 3, let's say 4, we get negative 5 over 18 times 2 times 4 plus 15 over 9, which is going to be a negative number, so greater than 3, f prime is negative. Here function is increasing, here function is decreasing, and at 3 the function levels off. So the function is increasing when D is between 3 and 0. The next question says, sketch a continuous function for each set of conditions. The first one says, f prime greater than 0 when x is less than 0. F prime is less than 0 when x is greater than 0, and f of 0 is equal to 4. So for this part, we know that f of 0 is 4. So let's say 4 is here. So this is our function here. Then it says that f prime greater than 0. So the function is increasing when x is less than 0, and the function is decreasing when x is greater than 0. So one possibility is going to be a graph like this one. The next question says f prime of x is greater than 0 when x is less than -1 and x greater than 2, and f prime is less than 0 when x is between -1 and 2, and f of 0 is 0. So I'm going to draw the table like this one, -1 here, 2 here. When x is less than -1, f prime is positive, and when it is greater than 2 is positive, and it's negative when x is between 2 and -1, which is here. When f prime is positive, the function is increasing. Between -1 and 2, the function is decreasing. And again, it's increasing. So the function looks like the following. The only thing which is going to constrain the graph is this point, which means that the function has to go through point 0. So this means the function has to go through here. So the function which is going to look like this. Now this point is -1 and this point is 2. You can see that when it's less than -1, the function is increasing here. Between these 2 points, the function is decreasing. It goes through point 0, 0, and then greater than 2, the function is also increasing. The next question says the range r of a small aircraft in miles at engine speed s in revolutions per minute is modeled by the function given here. Determine the range at engine speed of 2100 revolution per minute. This means that s is 2100, we have to find r. So we say r of 2100 is -1/2000 times 2100 squared plus 2 times 2100 minus 1500. If you simplify this one, we get 495 miles. The next part of the question says the engine speed is restricted to values from 500 revolution per minute to 3100 revolution per minute. So we know that s is between 3100 and 500. Within these values, determine the intervals on which the function is increasing or decreasing. So obviously we have to find r prime. R prime is -1/2000 times 2s plus 2. And we have to make this one equal to 0. From here I get -2s/2000 is equal to -2, -2, and -2 cancel. So s becomes 2000 here. Now I'm going to draw the number line. 2000 is here. The interval is 3100 to 500. Now I have to find the sign of f prime in each interval. Between 500 and 1000, if we pick a value, let's say 1000, then we get r prime is -1/2000 times 2 times 1000 plus 2. 2 times 1000 with this one cancels out, 2 minus 1 is 1, so it's positive. For 2000 to 3000, if we find, let's say, 2500, we substitute 2500 for S, we get R prime is negative 1 over 2000 times 2 times 2500 plus 2, which is going to be simplified to negative 2.5, which is negative number. So we can see that our F is going to increase here and decrease here. So we can say that R, the function, increases for S between 2000 and 500, and R decreases for S greater than between 3000 and 2000. The next question says, in an experiment, the number of certain type of bacteria is given by the formula N of T is equal to 100 plus 32 T squared minus T4, where T is the number in days since the experiment began and T is between 5 and 0. Find the interval of increase and decrease of the number of bacteria. So the first thing you have to do is to find the derivative. N prime is 32 times 2 is 64T minus 4T cubed, which is the same as, if we take the 4T out, we get 16 minus T squared equal to 0. So from here I get T equal to 0, or 16 minus T squared equal to 0, so T squared is equal to 16, or T is plus or minus 4. We know that the interval is between 0 and 5, so negative 4 we do not consider. So again, we are going to draw the number line. We know that 4 is one answer, and another one is 0. And the end of the interval is 5, so this is 5 here. Between 0 and 4, pick a number, let's say 1. So N prime becomes 64 minus 4, which is 60, a positive number. So we know that between 0 and 4 we are positive. Now between 4 and 5, let's pick 4.5, so we get 64 times 4.5, this is N, is equal to minus 4 times 4.5 cubed. If you simplify this one, you get negative 76.5, which is a negative number. Now we do the same thing, pick a number greater than 5, although we don't need to do that because our interval is between 0 and 5, so we can stop right here. And based on this number line, we know that when f prime is positive, function is increasing, and when it's negative, the function is decreasing. So the number of bacteria increases between the beginning to day 4, and then starts decreasing between day 4 and day 5. The next part of the question says, describe how your answer would be different if no interval were specified. Remember, the interval was t between 0 and 5. Now in this part, we don't have that restrictions anymore. So this means that if I make t prime n prime equal to 0, as before, we find that t is equal to 0 or plus or minus 4. So we have 4, 0, and negative 4 now. Now we have 1, 2, 3, 4 regions to consider. So for each region, we are going to pick a number and then decide on the sign of f prime. For less than negative 4, let's say negative 5, if we put it back in this equation, we get 180. So this means that this region f prime is positive. For 0 and negative 4, let's say we pick negative 1. If you simplify this one, you get negative 60. So this means that f prime is negative. Between 0 and 4, let's pick 1. So f prime of 1 becomes 60. So this is positive. For n prime, for d to be greater than 4, let's pick 5. We get negative 180. So this is negative. So this means our function is increasing here, decreasing, increasing, decreasing. So we can say that the function f, or correctly n, increases when d or time t is less than negative 4 and t is between 4 and 0. Our function n decreases when t is between 0 and negative 4 and t is greater than 4.